Hi students, welcome to the online classes. Today we are going to start a new lesson, that is reflection of light at curved surfaces. Reflection of light at curved surfaces. In your 8th standard, you learnt about reflection of light at plane surfaces. So, let us discuss some interesting facts before getting into this lesson. Have you ever burned a paper using the magnifying lens? So, if you keep a magnifying lens, if you keep a magnifying lens in the sunlight, so this magnifying lens can able to burn a paper. This magnifying lens can able to burn a paper. So, this is a magnifying lens. So, did you know that how this was happened? If the magnifying lens kept in a sun is capable to burn the paper, so it can made the light energy can burn this paper. How this was occurred? This was obtained due to the converging light rays. So, if this was the sun, the light rays are coming from the sun. If the light rays falls on the converging lens, if the light rays falls on the magnifying lens, all the light rays will focus to a point. So, whatever the light rays incident on this lens, all this light rays will focus to a single point. All that light energy is focused to a single point. We will call these light rays as converging light rays. What is meant by converging light rays? If the light rays are traveling towards a single point, all the light rays are traveling towards a single point. So, such light rays are called as converging light rays. If all the light rays are traveling towards a single point, such light rays are called as converging light rays. So, because of the light energy is completely focused to a single point. So, that is why that energy makes the paper to burn. So, here we are using magnifying lens. So, my question is, can you use a mirror to burn the paper like that? Can you use a mirror to burn the paper like that? In olden days, Archimedes, philosopher Archimedes uses a concave shaped mirror. I will explain in the later. A concave shaped mirror is a curved mirror. So, you can achieve such effect, the magnifying lens effect, by using a concave mirror. So, Archimedes uses a concave mirror to burn the battleships of the enemies. He will use a mirror to burn. Similar to this effect, he will use a large shaped mirrors. The Archimedes used large shaped mirrors to burn the battleships of the enemies. So, yes, we can use the mirrors to burn the paper like this. So, how? So, which type of mirrors will be used? But it is not the mirror that you are using at home. So, to obtain such an effect, we have to use curved mirrors. So, in this lesson we will see how this happened, how the reflection will be occurred at the curved surfaces. And especially in this lesson we will deal about the spherical curved surface. Before getting into that, let us recollect what we know about the reflection. So, now what is meant by reflection? So, when a light ray is incident on an object, it bounces back into the same medium. For example, if you are watching any object, here I was able to view this object. So, how this object was viewed by you? what was happening here? Here the light rays will falls on this object and this object will reflect the light, and the reflected light reaches to our eyes, to my eyes. That's why I was able to view this object. So what was happening here? Reflection. The light coming from the air strikes the object and bounces back into the air only. So when light travels from one medium and bounces back into the same medium, when light incident on an object and bounces back into the same medium, that phenomenon is called as reflection. What is reflection? When light is incident on an object, when light is incident on an object, when light is incident on an object, it bounces back into the same medium. It bounces back into the same medium. This phenomenon is called as reflection. This phenomenon is called as reflection. So let us learn some basics. Let us recollect the basics from your 8th standard. Let us observe the reflection at plane surface. For example, this is a plane surface. This is a plane surface. Let us say this is the surface of the mirror. Why we will learn about the mirrors? Mirrors are the perfect reflectors. It will reflect 99% of the light incident on it, mostly 100% of the light. So if it is a mirror, only one surface has the reflecting surface. So if you have the mirrors at your home, only one side you can view your image. On the other side, it is not a reflecting surface. So only this is the plane side is a reflecting surface. So when a light ray is incident on a mirror, it will reflect into the same medium. So light comes from the air medium and again bounces back into the same medium. So in order to deal with angles, to measure the angles, so we need to draw a normal line at the point of incidence. Where the light is incident? At this point. We will call this point as point of incidence. And the line normal to the plane which is perpendicular to the plane, is called as normal line, and this light ray is called as incident ray. And this light ray is called as reflected ray. The angle made by the incident ray with the normal is called as incident angle, and the angle made by the reflected ray with the normal is called as reflected angle R. What are the laws of reflection? This incident ray, normal line, reflected ray lies on the same plane. That is first law of reflection. And second one is angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So whatever the angle of incidence is, the reflected ray will also makes the same angle. So in order to picturize the diagram, in order to draw the reflections, you need to draw initially normal line. So then you can find the angle of incidence, and from that angle of incidence you can draw the reflected ray. Because why? Because angle of incidence is equal to angle of reflection. So these angles are measured from the normal line. So that's why it is very important to draw a normal line to draw the diagram. Why? Because the angles are measured from the normal line only. So keep that point in your mind. Initially, for a surface you need to draw a normal line. So this is the basic things that we want to know in order to get into this lesson. And let us discuss an activity, and later I will say what was the conclusion that we got from that activity. So these are the basics you have to recollect from your 8th standard. So let us consider a wooden block. consider a wooden block and place two nails, place two nails on it, two nails, place two nails on it. So, this experiment, this activity has to be done in a dark room. So, if you place two nails on a wooden block and place a candle near to it, place a candle near to it and do this experiment in a dark room. If you place a candle near to this block, you have placed a candle near to this block, the shadows of these nails, the shadows of these nails will be seen like this. The shadows of this flame, the shadows of these nails will be observed on the ground. These are the shadows, shadows of nails will be observed like this, and just change the distance. Now keep the candle at large distance. Now keep the candle at the large distance. So now observe the shadows here. So what is your observation? So when you keep the candle at a large distance, the shadows will be like this. So what is your observation? Here the shadows are at some angle, but here the shadows are parallel. Shadows here will be parallel. Shadows here are parallel. Shadows here are parallel. So what is your conclusion from that? What is your conclusion from that? Why? Because when the source is near, this is the source of light. Candle is the source of light. When the source of light is near, the light rays will be considered as unparalleled. The light rays will be, when the source is near, the light rays are not parallel. When the source is at large distance, when the source is at large distance, then the light rays coming from this source will be considered as parallel light rays, parallel light rays. For example, the sun is at, is it near to us, sun? No, sun is very large distance. So the light rays coming from the sun can be considered as parallel light rays. When the source of light is near, the light rays coming from that source is not parallel. When the source is at large distance, then you can consider the light rays coming from the source as parallel. So let us discuss this again. Let us see. I will explain it again, not with an activity, with different thought. So for example, so a torchlight is on. For example, say the torchlight light will be like this, right? So if you consider the light rays here, if you consider the light rays are not parallel here. The distance is not same. The light rays are not same. This is the source of light. So near to the source of light, the light rays are not parallel. Near to the source of light, the light rays are not parallel. But if you consider the same light rays at large distances, if you consider the light rays at here, so what will you observe? These light rays will be parallel. So what is your conclusion? If the source of light is at large distances, the light coming from the source will be considered as parallel light rays. If the source is near, then the light coming from that source are not parallel. The light rays are not parallel. This is the observation. So let us start. So mainly in this lesson, we will deal about reflection of light at spherical surfaces, at spherical curved surfaces. So spherical curved surfaces, we will deal about spherical curved surfaces. Now spherical curved surfaces. Spherical curved surfaces means the surfaces which are part of a sphere. These are the surfaces which are part of a sphere, For example, consider a rubber ball. Cut this ball like this. If you cut this ball like this, you will get a piece. So you can call this as spherical curve. What is meant by a spherical curve? the spherical curve is a part of a sphere. Spherical curve is a part of a sphere. Spherical curve is a part of a sphere. So, the mirrors which are in the shape of spherical curves are called as spherical mirrors. Spherical mirrors. So, if you think this is a sphere means 3-dimensional object, you have to view it as a 3-dimensional. So, if I cut like this, here you can remind some surface. So, that surface is called as spherical surface. So, you will get a curved surface like this. So, this inward bent surface is called concave surface, and this outward bent is called convex surface. Outward bent surface is called as convex surface. So, this inward bent surface is called concave surface and this outward bent surface is called convex surface. So, here the mirror, if you consider the mirror, only one side will be reflecting surface, other side will be non-reflecting surface. Some painting will be there at the other side of the mirror. So, if the reflecting surface is present on the concave surface, then it is a concave mirror. So, you can represent the concave mirror like this. So, here I have drawn some lines. This is the painted side and this is the reflected side, in which side I didn't draw the lines. So, this is the reflecting surface, this is the painted surface. So, here what is the reflected surface? The concave surface. Inward bent surface is the reflecting surface. If the reflecting surface present on the concave surface, then it is a concave mirror. If you consider a spherical surface, if you consider a spherical curve, the inward bent surface is called concave surface, the outward bent surface is called convex surface. So, if you consider this structure here, this is the bend. Let us imagine this is a spherical surface. So, this inward bend structure is the concave surface and this outward bend surface is the convex surface. If the reflecting surface was towards this side, if the reflecting surface is in this side, so this is a concave mirror. If the reflecting surface is in this side, then it is a convex mirror. If the reflecting surface present on the convex surface, then it is a convex mirror. So, this is the reflecting surface, this is the concave surface. So, this is the painted surface. So, on the mirror only one surface is the reflecting surface. If the reflecting surface present on a convex surface, then the mirror is a convex mirror. If the reflecting surface is present on a concave surface, then it is a concave mirror. So, now to understand the reflection, so initially this is the incident light ray. If I asked you to draw the reflected light ray, what is the correct procedure? This is the incident light ray and I asked you to draw the reflected light ray. You don't have to write simply like this. You need to draw a normal line and measure the angle between incident and normal line I, and with the same angle you have to draw the reflected ray. So, in order to draw the diagrams, in order to know the reflected light ray, initially you must know about the normal line. So, for a plane surface, what is the normal line? The line which is drawn perpendicular is the normal line. So, this is the normal at this point. If you want to draw the normal at this point, draw a line perpendicular at this point. So, this is the normal line at this point. If you want to draw a normal line at this point, you need to draw a line perpendicularly. Then this line represents normal line. So, in this way, wherever you want to draw the normal line, you have to draw a normal line by making an angle 90 degrees. You have to draw a line perpendicularly. So, but in the case of spherical mirrors, it is not a plane mirror to draw a normal line like this. This is not a plane surface. This spherical surface is not a plane surface to draw a normal line this. But how can you draw the normal line? So, how the normal lines will be situated for a spherical surfaces? How the normal lines will be situated for the spherical surfaces? So, let us see about that. So, to understand about the normal lines for spherical surfaces, consider a plain rubber surface. Consider plain rubber surface. So, consider a rubber. So, I have considered a plane of rubber. So, a plain rubber was considered. So, it can be bent easily. So, consider a rubber like this and attach nails to this rubber. So, this is the plain rubber surface. So, consider plain rubber surface and nails are attached in this direction. So, if you bend the rubber plane like this, what you will observe, it will be bent, the plane surface will be bent and the nails will be situated like this, right. The nails will be situated like this. So, if you observe the nails, these are pointing towards a fixed point. These are pointing towards, they are converging to a point. So, these are the normal lines for a plane surface. Is this nail is fixed perpendicularly? Yes. So, these are the normal lines for this plane surface. So, this is the plane surface. These are the normal lines for the plane surfaces. If it is curved, what was happening? If you curve this plain rubber surface, the normal lines, all the normal lines are focused to a point, are directed towards a point. So, this is the center of the curvature. Similarly, if you bend this rubber sole in this direction, then how it will looks like? So, here the nails will looks like this. So, here all the nails appears to be converging to a point. Here nails are converging to a point. Here the nails are diverging. Diverging means moving away from a point. Here nails are converging to a point. Nails are converging to a point. Here nails are diverging. Diverging means moving away from a single point. Here the nails are moving away from a single point. Converging means directing towards a single point. All the nails are directed towards a single point. Here all the nails appears to be diverging from a point. So, that point is nothing but center of curvature. This point is nothing but center of curvature. What? So, if you imagine, these are the spherical surfaces. So, these are the spherical surfaces. Spherical surfaces means these are the part of a sphere. So, for that sphere, if there is a sphere, so this is a part of the sphere. So, for that sphere there is a center of curvature, right? There is a center of curvature for that sphere. There is a center for that sphere and that center is called as center of curvature. Now, there is no sphere at all, only curve is there. the remaining sphere is cutted off. So, this center is called as center of curvature. This is a part of a sphere. This particular curved surface, we are learning about spherical surfaces. That spherical surface is a part of a sphere. So, since it is a part of a sphere, you will have a center for that sphere, right? You will have a center for that sphere, and that center is called as center of curvature, and the center is called as center of curvature. So, if you consider a spherical surface, what I said, this is a spherical surface. Spherical surface means this is a part of a sphere. So, you can construct a sphere with this spherical surface, right? You can construct a sphere with this spherical surface, and the center of that sphere is called as center of curvature. So, here the line joining, these are the normal lines for the plane surface case. So, what will be the normal lines for the curved surface? The normal lines will be line joining the center of curvature and the point on the curve. If you want to draw the normal at this point, you need to draw a line connecting this point P and center of curvature C. So, then this line represent normal line. For a curved surfaces, for a spherical curves, how you have to draw the normal lines? If you want to draw the normal line at this point, the line joining the point and the center of curvature will give normal at this point. Again repeat, if you want to draw the normal at this point, the line joining this point and center of curvature will denote the normal line. So, the normal lines for a curved surfaces, for a spherical surfaces will be drawn like the line joining the center of curvature, and the point on the curved surface will represent the line joining the center of curvature, and that point on the curved surface will represent the normal line for that spherical surface. Let us look into that again. So, again, for example, if it is a plane surface, if you want to draw a normal line for this plane surface, you have to draw a line perpendicular, then this line represents normal line. But if you consider a spherical surface, for this spherical surface there is a center of curvature. Since it is a part of a sphere, so the center of that sphere is called as center of curvature. If you want to draw a normal line at this point, the line joining the point and the center of curvature will be represents a normal line. So, this is the normal line at this point. If you want to draw the normal line at this point, the line joining the center of curvature C and this point represents the normal line. So, this is the normal line. So, why we learnt about normal line? Because we are taking the measurements of angles from the normal line only. So, this is the incident light ray. You have to take the angle of incidence, you have to measure the angle of incidence from the normal line. So, that is why we already know about how the normal lines will be for a plane surface, and for a spherical surface, the normal lines will be drawn as the line joining the point and the center of curvature. So, this is the normal lines for the concave surface. If it is a convex surface, so for the concave surface, so let us say this is the concave mirror. So, let us say this is the convex mirror, the reflecting surface is the present on the convex surface. So, if you consider the convex surface, for this curve, the center of curvature will be lies here. So, why? Because the sphere can be constructed like this. So, this is the center of curvature. If you want to draw the normal at this point, the line joining the point and the center of curvature will represent the normal line. So, this is the normal line. So, if you want to draw the normal at this point, the line joining the point and the center of curvature represents the normal line. So, we have seen how the normal lines will be there for a spherical surfaces. So, in the latter session, in the next session, we will know about how the reflections will be occurred at curved surfaces. With this session was completed. Thank you.